Three random samples have been obtained. At the 0.05 level of significance, is there enough evidence to support the claim that the distributions of the populations are different? Use the Kruskal-Wallis test. So first, we have to combine and sort the data. So the lowest value is 3, and that's found in samples 1 and 2. Next is 4, which is found in all 3 samples. Next is 5 from sample 3. Then 7 from samples 1 and 3. Then 8 from sample 2. 9 from sample 2. And 10 from sample 3. Now I want to rank these. And there's a tie for the first and second position. So we have to average these, and they both get a rank of 1.5. And there's a tie for the third, fourth, and fifth positions. So we have to average those, and they all get a rank of 4. 5 gets a rank of 6. There's a tie for the 7th and 8th position, so if we average those, they both get a rank of 7.5. 8 is in the 9th position, 9 is in the 10th position, and 10 is in the 11th position. So the claim is that the distributions of the populations are different. And this is the alternative hypothesis. So the null hypothesis states that the distributions of the populations are the same. Alpha is 0.05. Now let's look at the table to find the critical value. Our sample sizes are 4, 4, and 3. So the critical value is 5.5985. Sample 1 had a size of 3. Sample 2 had a size of 4. Sample 3 also had a size of 4. Capital N is the sum of all of the sample sizes, so that would be 11. R1 is the sum of the ranks from sample 1, so that would be 13. And then if we square 13, we get 169. R2 is the sum of the ranks from sample 2, and that would be 24.5, which, if we square that, we get 600.25. And then finally, R3 is the sum of the ranks from sample 3, and we get 28.5, which, if we square that, we get 812.25. Next, we have to use the formula to calculate H. So this will be 12 over 11 times 11 plus 1 times 169 over 3 plus 600.25 over 4 plus 812.25 over 4 minus 3 times 11 plus 1. Now I want to show that middle part on the calculator. So I'm going to type that into the calculator and get 409.4583 repeating, and then convert that to a fraction, which is 9,827 over 24. So we have 1 over 11 times 9,827 over 24 minus 36. And that is 1.2235. So H is less than the critical value. So we fail to reject the null hypothesis. And the conclusion would be, at the 0.05 level of significance, there is not enough evidence to support the claim that the distributions of the populations are different.